In this problem, we are asked to see if enrolling adults into water aerobics will cause them to have less depression. I imagine that's what the researcher wanted to show. However, at the end of this problem, it will show that the adults actually have more depression, which is an interesting outcome when you think of its implications. Now, in order to test this, we are going to use a two-sample t-test. And because we do not know the population sigma, that's why we are using a t-test. The reason we're not using a matched pairs experiment, as I started to draw in my chart over here, we're not going to use matched pairs because we did not use twins, we did not use the same person who had both treatments, and we also did not have the researcher attempt to pair off the subjects based on some common criteria, such as are you still married, such as past depression scores, such as age or sex, or any of these types of factors that could potentially affect depression levels. Since we are doing a two-sample t-test, we have our hypotheses written here below. The null hypothesis is just saying that the two groups do not have a difference in their means. As we can see, this is probably incorrect because one mean is 26, whereas the other mean is 22. However, we need to calculate the t-statistic before we can be certain of this. The alternative hypothesis states that there is a difference between the two groups. We have two ways of writing this. We can either say that the means are not equal to each other, or we can write that the difference between the two means is not equal to 0. I much prefer this interpretation because we are eventually going to calculate our sampling distribution where we expect the mean difference to be 0, and what we're going to find is that our mean difference is quite larger than 0, and it's so large and so far away that the probability of this happening is much too small. The next step would normally be to see if the conditions for the two-sample t-test are met. However, in the problem, they state that the researcher is confident that the data is normal, even though I don't believe them. We will take their word for it and skip this next step in the problem. We move on now to calculate our test statistic, which in this case is the two-sample t-test. The important parts of this formula is that on the top of the fraction we have the difference in the sample means, which in our case we find to be 4, and next to it we have the difference in the population means, which we expect to be 0 in this problem. We can see that in our null hypothesis. On the bottom of the fraction, we would normally see something like s over root n. However, in this problem, we have multiple standard deviations in multiple samples, and so this has to be taken into account by using this massive square root. And underneath this square root, we have both the standard deviation of the first group and the standard deviation of the second group, and also the sample for the first group and the sample for the second group. Plugging in our numbers, we will be able to calculate that the t-value ends up being 2.514, and since I'm doing this by hand in the video, we will use that the degrees of freedom is equal to 8. Now, if you were to use your calculator or some other software to calculate this test statistic, the calculator has another way of calculating the degrees of freedom, and their degrees of freedom will be some decimal. It's something like 13.5 when I did it on my calculator, but since we do not have that formula, and if you were to do this on an AP test or something, you would just use the rule that you would do n-1 for the smallest sample that there was in the problem. In that case, it's 9, and so that's why I have 8 degrees of freedom used here. Using this t-value, we can start to draw our distribution of our sample, where we expect the mean difference to be 0. Now, in this case, our t-value is 2.514, which puts us over here in this tail. And if you look this up in the back of your book to find a p-value, you will find that the p-value of this tail is going to be between 0.2 and 0.1. Now, since we are doing a two-sided test in this problem, which we can see from our alternative and null hypotheses, right here where we say it's not equals as opposed to greater than or less than. That means that we need to double our p-value because we could have easily had a sample that put us on this side. That's the theory of the two-sided test. And therefore we need to symmetrically double this p-value. And because of that, the final p-value for a hypothesis test is going to be between 0.02, I'm sorry, I've been doing these wrong. This is 0.01, this is 0.02, this is 0.04. My apologies. Our p-value needs to be between 0.02 and 0.04, which is a major difference because this means that we can reject the null hypothesis. So since our p-value is less than 0.05, which is generally the standard, since our p-value is less than this, we are allowed to reject the null hypothesis, and we are allowed to accept the alternative hypothesis that there is enough data to support the alternative hypothesis, which implies that there is a difference between engaging in water aerobics and not engaging in water aerobics. However, I would like to point out it's interesting that in this case it makes you more depressed to be in water aerobics, so maybe older people do not enjoy being in the water and exercising. The final question that they ask us in this problem is to calculate a 95% confidence interval. The formula for this confidence interval is given here, if you can see my messy handwriting. The only part of this formula we have not already solved is this T star value written right here. That T star value you can find in the back of your book. If you go to where our degrees of freedom are equal to 8, and you have to move along the table, and then you have to go between the upper tail probability being 0.05, I'm sorry, not 0.05, since we're doing two-sided test, you need to find where the upper tail probability is 0.025, or on the bottom of the chart it says that it's for a 95% confidence interval. So that's the correct column to go under, one of these two options, and the correct row is for the degrees of freedom to equal to 8. If you can do that properly, you will find that the T-star value for this problem is going to be 2.306, which we use here, and in doing that we calculate our confidence interval to be 0.331 and 7.669. This most importantly does not include 0, which is the reason that we were able to reject our null hypothesis and accept that there is a difference between the two groups.